Okay, welcome to Unit 2, Lesson 6. In this lesson, we're going to use what we call implicit differentiation. Now, implicit differentiation we're going to use throughout the semester and even in Calculus BC. But let's just talk about why implicit differentiation is needed for a second. Sometimes there are functions that it's difficult to solve for y. Now we see that this is a circle, and we could easily solve for y and get y is equal to the square root of plus or minus the square root of 1 minus x squared. So if we were to solve for y, I'm sorry, my board is not on, sorry. If we were to solve for y, we would get something that looked like y is equal to plus or minus the square root of 1 minus x squared. And this plus or minus makes it difficult to take the derivative. So instead of using the plus and minus, what we're going to use is implicit. Now I have to tell you, implicit differentiation means that we're taking the derivative with respect to a letter or respect to a particular variable. Up until this point, we've taken the derivative with respect to x. And so if I have y equals x squared, what we've said so far is that y prime is equal to 2x. And the reason we actually have to use chain rule here, what we just learned. So yes, we have to do the 2x, but technically we also have to take the derivative of x. And so we were taking the derivative with respect to x. So anytime we have dx divided by dx, that's just 1. So we just wrote 2x. But if I have y squared and I'm taking the derivative of that, I still get the 2y, but then I have to take the derivative of y with respect to x. So I end up with 2y dy dx. And that is what we call implicit differentiation. The derivative of anything with respect to itself is 1. So in the next unit, we're going to look at dt. So anytime we take dt, that's equal to 1. Or anything with respect to itself, the derivative of anything with respect to itself is 1. So that is why we haven't technically done this. We haven't done dx dx because it's just 1. But when we add y to the mix, now we have to do dy dx. So let's just talk about the steps to differentiating implicitly. We want to differentiate both sides with respect to x, and then we're going to collect all terms involving dy dx to one side and move everything else to the other side of the equation. And then we're going to factor out dy dx and solve for dy dx. I know this seems like a lot of steps, but I think you'll get the hang of it. The biggest thing to remember is that when we take the derivative of anything in respect to itself, it's 1. But if we're finding dy dx, then we have to take any other variable has to be differentiated with respect to x. So let's do an example. Okay? So we've already talked about this. We've kind of broken this up into parts. When we take the derivative of x squared, it's 2x times dx dx, which is just 1. But then we have to take the derivative of y, which becomes 2y dy dx. And the derivative of a constant, any constant, is 0. So what we want to do is we want to find dy dx. So to do that, we're going to solve for dy dx. So the first thing is to subtract 2x from both sides. So I get 2y dy dx is equal to negative 2x. And since I'm solving for dy dx, my next step would be to divide both sides by 2y. So we get dy dx is equal to negative x over y. The 2's cancel. And that's what we say dy dx is. So what is dy dx? Dy dx is still the equation, the slope of the tangent line. So if I were to take a tangent here, and let's say this point is 2, 3, That point is 2, 3. Then the slope at that point would be negative 2 over 3. It would be negative 2/3. And of course, I just made that up. I don't know what exactly that point is, but that is how we would find the slope at that point, which makes sense because we see that the slope is negative. And so our answer is negative. Okay, let's do another one. So anytime we have y or something other than x, our answer will have dy dx in it, or dA dx, or whatever the variable is. So this would be 2. The derivative of y is 1, but the derivative of the inner function, the outer function, y itself, is dy dx. Then we would do power rule on this, so this gives us 2x and technically dx dx, which is 1, plus, what's the derivative of sine y? It's cosine of y. Then we have to take the derivative of the inner function, which would be dy dx. So we're using chain rule. Now what we want to do is get all the dy dx's on one side. So I have 2 dy dx minus cosine y times dy dx, and that's equal to 2x. I'm going to factor out the dy dx. So I get 2 minus cosine y is equal to 2x. Now to solve for dy dx, I divide both sides by 2 minus cosine y. So that gives us that dy dx is equal to 2x over 2 minus cosine y. And that's our answer. You may want to, again, pause the video and try a few of these on your own. And I will do them, but I'd like for you to try them first. Okay? All right, so for this one, we're going to take the derivative of y cubed. We're going to use the power rule first, so that gives us 3y squared. And then we take the derivative of y itself, which is dy dx. Plus, we use the power rule. And then we take the derivative of y itself. And this will just be dy dx minus 2x. And remember, the derivative of a constant is 0. Then we can combine steps here. I'm going to factor out dy dx. And I'm not going to make up stuff. That should be 3y squared plus 2y minus 5. And I'm going to move the 2x to the other side, equals 2x. So then we get dy dx is equal to 2x divided by 3y squared plus 2y minus 5. And that's our answer. This is similar to the circle that we did before. This is a hyperbola. So this gives us 2x, and remember the derivative of x with respect to x is just 1, minus 2y dy dx, and that's equal to 0, because the derivative of a constant is 0. You thought you had me there, didn't you? So this is negative 2y dy dx is equal to negative 2x divided by negative 2y. I get dy dx is equal to x over y. Okay, so for a problem like this, you have to remember to use chain rule and also the product rule inside of this. So this is going to be a little bit more difficult. Now, because we're getting a little bit more difficult, let me just say that as a notation, dy dx can be written as y prime. So on this one, I'm going to write dy dx as y prime just to kind of save some writing there, okay? So the first thing I have to do is take the derivative of this inner function. And to take the derivative of this inner function, I have to use product rule. So the derivative of x times y using product rule is we keep x the same and we take the derivative of y, which is y prime, plus we keep y the same and we take the derivative of x, which is 1. So that is the derivative of that inner function. We had to use the product rule. Then I'm going to take the derivative of the outer function, and remember, this is one I told you that makes life easier if we remember it. It's 1 over 2 square root of xy. Now the derivative of x is 1, and the derivative of 2y is 2y prime. So now what I have to do is I have to get all these y primes together. So I'm going to have to multiply this through, I'm going to have to distribute this to get the y primes together. Or do I have to do that? I could just multiply by 2 square root of xy. So if I did that, I get x y prime plus y is equal to, multiplying both of these by 2 square root of xy gives me 2 square root of xy minus 4 square root of xy y prime. So now I'm going to move all my y primes to one side and everything else to the other side. So that means I'm going to add this to the left side and subtract this from the right side. So I get x y prime plus 4xy radical y prime is equal to 2xy minus y. So now I need to factor out my y prime, so I get y prime x plus 4 square root of xy is equal to 2 square root of xy minus y. So that leaves us with y prime is equal to 2 radical xy minus y over x plus 4 radical xy. And your answer may look a little differently if you multiply differently, but it should be the same answer. Okay, once again, we have to remember we have to use product rule. So to make my life easier, you know what I'm going to do? I'm just going to divide through by this 2. Makes my life easier because now I just have sine x cosine y equals to 1/2. And when I take the derivative of that 1/2, it's going to give me 0. So that just makes my life easier. So I have to use product rule. So I keep sine x the same. And then the derivative of cosine y is negative sine of y. But then I have to multiply that by the derivative of y, which is y prime. Plus, I keep cosine y the same, and I take the derivative of sine x, which is simply cosine x. And that's going to equal to 0. So solving for y prime, I'm going to move the cosine y, I'm going to add sine x, sine y, y prime to the other side, and I get sine x, sine y, y prime is equal to cosine y, cosine x. And dividing, I get y prime is equal to cosine of y, cosine of x, divided by, I'm going to write sine x here and sine y here, because then I can write this as y prime is equal to the cotan y, cotan x, using a simple trig identity. And it kind of makes that problem look a little bit nicer. Okay, most of the time my students do this, they try to use chain rule on that, and you can use chain rule on it, but let's just do something a little easier, and let's just take the square root of both sides. So we get sine pi x plus cosine pi y is equal to plus or minus radical 2. And it doesn't matter that that's plus or minus, because when we take the derivative, it's still 0. So taking the derivative of both sides now gives me, I guess I can't call that y. That's why there's nothing there. So the derivative of this is going to give me, I have to use chain rule, so the derivative of pi x is pi, and then sine pi x would be cosine pi x. This would be pi negative, let me just make that a subtraction sign, makes my life easier, because the derivative of cosine is negative sine, so it would be negative sine pi y, and then what else do I need here? You got it, dy dx, and that's equal to 0. So this gives us that pi sine pi y times y prime is equal to pi cosine pi x. And then dividing both sides, the pi's cancel, and I get y prime is equal to cosine pi x over over sine pi y. Now I can't make that cotangent because I have two different variables. So I can't simplify this any further because I have two different variables. Okay, so just trying to see how much more we're doing in this. Okay. So cotangent is 1 over tangent, and the derivative of tangent is secant squared. So the derivative of cotangent, I think, is cosecant squared. And it's also, we know that it's negative, and I'm not sure why I'm having a hard time writing cosecant tonight. But it's negative cosecant squared y, but then I still have to do dy dx. And that's equal to the derivative of x is 1 minus dy dx. So once again, bringing everything to one side, I get negative cosecant squared y times y prime plus y prime is equal to 1. We are going to factor out a y prime, and I get 1 minus cosecant squared y is equal to 1. So y prime is equal to 1 over 1 minus cosecant squared y. And that may be some property, but life's too short. Okay? Once again, we're going to have to use product rule and chain rule here. Okay? First part of this is pretty easy. That's just 2x. But this part is a little bit more tricky because I have to use the chain rule. So I have to take the derivative of xy. To take the derivative of xy, I have to use product rule. So I keep x the same, take the derivative of y is y prime, plus I keep y the same, the derivative of x is 1, parenthesis, and then the derivative of sine xy is cosine xy. We need to solve for y prime here. I'm just going to do it the easy way. I'm going to divide by cosine xy. And then subtract y and divide by x. So I get 2x cosine xy minus y, and then all of that divided by x. This is probably a pretty ugly way to write that, but I'm just being lazy. Okay, one last type problem. We still have to be able to find the equation of the tangent line. So we're going to do the exact same thing because remember the slope is dy dx, okay? So we find the derivative of this, which is 2x minus, okay, let me just say here, this is important. We have to use product rule. But this negative is important. One of the things I stress with my kids is that parentheses are important. All parentheses matter, okay? So we have to use product rule. So we're going to put a parenthesis here because we have to remember we have to distribute by this negative in the end. So we keep x the same. The derivative of y is y prime. Plus, we keep y the same. The derivative of x is 1. And then this is going to be 2y, y prime equals 0. Okay? So I'm going to go ahead and distribute this y prime. So I get 2x minus xy prime minus y plus 2y, y prime equals 0. I'm going to factor out a y prime from all the y primes and move everything to the other side. And I'm going to do all that in one step because, once again, it's getting late and I'm tired. So I factored out a 2y minus x, and that's going to equal to, I'm moving the 2x over, and I'm moving the y over. So then y prime is equal to negative 2x plus y over 2y minus x. Now, they give us the point, negative 1, 2. So we know x is negative 1 and y is 2. So to find dy dx, I'm just going to do a quick plug and chug. Now, if my math is wrong, please forgive me. Negative 2 times negative 1 is positive 2. Y is 2, so this would be plus 2. 2y would be 4. And negative 1 would be 1. So I get 4/5. And I hope my math is right. So my slope is 4/5. My point is 1, 2. So I have enough information to write the equation of the line. So recall from the beginning of this unit, we're just going to use the point slope formula. So we have y minus 2 is equal to 4/5 x minus negative 1. And also recall that we do not have to simplify this. This is good. Okay? So what I'm going to have you do is actually not in your notes, but I think this is kind of a complicated topic. So I think you should practice this and just try to do 1 through 15 odd in the textbook. Okay? So try section 2.5, 1 through 15 odd. Again, if you have any questions, text me, and we will finish this lesson in the next video.